Finding antiderivatives by hand is an important skill to master in Calculus 2. And the reason why is that instructors of courses that use Calculus 2 as a prerequisite will expect you to be able to find antiderivatives of certain functions by hand whenever they are needed. On the other hand, it's also important to understand that programs like Mathematica can integrate just about anything that you want fairly quickly and fairly easily. So in this particular Calculus 2 class, I want you to feel free to use Mathematica to check your answers on any problem where you are being asked to find an antiderivative by hand. So to show you how to do that, let's look at an example. Suppose I want to find the antiderivative of x squared times the secant of x cubed times the tangent of x cubed. Now, to analyze this thing, I want to realize I have a composition here of secant with x cubed and tangent with x cubed, and x cubed is the inside function in both of those. I also know that the derivative of secant of x is secant of x times tangent of x, and since this is an x squared, all of those things lead me to believe that it is reasonable to set u equal to x cubed, and du will be 3x squared dx in this problem. And if I think about this u substitution, I am missing this 3, so I want to fix the integral up as 3 over 3, and let me clean up that notation. So I've got 3 over 3 times the integral of x squared secant of x cubed times tangent of x cubed dx. And when I start to go looking for the du, that's part of the du, that's part of the du, and that's part of the du. So those three things go together to form the du, and when I rewrite the integral, I've got 1/3 times the integral of secant of u times tangent of u du. And I know that secant of u times tangent of u is going to go back to the secant of u. So my integral is going to go back to this 1/3 times the secant of u plus any constant that I want to add. And then finally, to get to my final answer, I am going to remember that u itself is x cubed, so this secant of u is actually going to be the secant of x cubed plus c. Now, how would I check this answer using Mathematica? Well, let me go over to my Mathematica window and we will see how I do that. Mathematica's integration command is just integrate. And as all functions, I have to have square brackets. And then I simply feed it, what do I want to integrate? My integrand was x squared times the secant of x cubed times the tangent of x cubed. And then I have to tell Mathematica that I do want to integrate with respect to x. And notice that Mathematica says that the answer is indeed what we got, x cubed over 3. Just to go back to our other window, that does indeed agree with our answer, although Mathematica does not write down the plus c's. Going back to Mathematica, I want to kind of analyze what we're really doing in this integrate command. This part here is the integrand. And this x is coming from the dx part of the integral of f of x dx. In other words, what I basically want to do when I'm looking at a Mathematica command is that we are going to always have integrate the function comma x.